Hello, so welcome to AI episode 4. This will be my the first lab, which is gonna be on linear regression. The process is will be first importing the libraries, then getting data, then we have to explore and visualize the data to like kind of see what it looks like and stuff. And then you have to clean up the data because you don't know if the data is gonna be like messy. There could be problems in the data. And then separation and splitting, which I'll get to when we get there, and transform the data. And since there's a lot of stuff, we'll be continuing it in the next episode, which is training and evaluating the results. The first step, of course, is to import the libraries. I'll be doing this in Python with Jupyter Notebook. So you can see here, there's a bunch of stuff to import, like matplotlib here to plot it, pandas for storage, etc., etc. And this actually is where we'll be getting our data from. sklearn, which is like the training thing, like this, the linear model here for the regressor, and this actually will be using here. So getting the data, we use a standard training data set for AI, for like examples, which is the California housing data set. So we can just fetch it and then just kind of put it into this df variable here. And what's in them is like stuff like median income, house age, average rooms, average bedrooms, latitude and longitude, that stuff. So let's explore this data. So let's see what's in it. So you can print out the shape, feature names, target names, and just to describe, which gives this thing here. So like you can see how much data you have, mean, standard deviation, minimum, maximum, and you'll notice some outliers here, like the average occupancy, the mean is 3, but the max is 1,243, which could be a problem later. Let's graph it. So we can graph it with a heat map and with a histogram. So this is what can graph a histogram, and this is what graphs a heat map. And the feature correlation heat map is actually really important because it just shows how much two things are correlated. It's like for income, you can see like median income here and median house value here are really correlated, like 0.69 correlation, which is pretty correlated. But you can see latitude and longitude are very inversely correlated here. And the average rooms and average bedrooms are very correlated. So the rest of them don't really have correlation, which makes sense. Like, what does average bedrooms have to do with house age? Not really that much, so it's really low. But stuff like average rooms and average bedrooms have a really high positive correlation. Because yeah, of course, if a house has a lot of rooms, it's gonna have a lot of bedrooms, you know. And this is the thing we're probably actually interested in, is the median income to median house value, which is pretty high. So you'll be able to see that when we graph that data as well. So this is just a low graph to just kind of see like where these houses are. It's graphed on a scatter plot with longitude and latitude. You can see it on this map here. So one thing to think about, actually, I'll leave you to think about that, is about logits. The rest of the data that we're putting in are logits, but what about longitude and latitude? Do those count as logits? Something to think about. Here's something we'll be graphing it more. We'll be comparing all of them to the target, which is median house value. And we'll see some of them look really weird because they have a couple small outliers. And these could be a problem because they cause the graph to look very weird. So we do not like them. So most of the work actually in training a model is you want to clean up the data. So like here we have to check for missing values, and here to drop duplicates. So like we also want to drop columns that don't matter. Like maybe some houses have like address numbers. Address numbers do not matter, so we could probably remove them, like that stuff. And also we want to trim out outliers. And if data is missing, which on this one it's not because this data set is already pretty clean, we can either fill it in the data or just dropping the missing data. Our data set is pretty clean here, so we don't have missing values, we don't really have duplicate rows, that stuff. One thing we can do is to get rid of the outliers. So with this, it basically cuts off the lowest 10% and the highest 10%. It will clean out that data. So you can see it looks a lot better now because I cut out the data for these four. So now something that really important to do is separating the data and splitting. So separation basically means cutting out the target. So you turn the inputs, which is everything except the median house value, into a matrix. You take that median house value and put that into a vector. So this is what the model knows what it's getting in and what it has to put out. And the other thing you have to do is that you have to split the data into the training and verification or testing data. The training data is used to train the model, and the verification or testing data is used to test the model, so assess how it's doing basically. And one thing you gotta remember is that you should always split the before transforming it and transforming the data. So transforming is really interesting for us because the thing I talked about, we're not actually using the sigmoid function because we're doing linear regression, I'm pretty sure. So yeah, we'll be using linear scalar instead. So what standardization does is it basically makes sure the numbers are normalized with around 0 with a standard deviation of 1. So you can see that if this is not actually the data, but if this was the data, you can see it goes from 100 to 300, which we do not want. So instead, when we normalize it, it'll be going from 0 to -3 to 3. These would be the standard deviations, like from 1 to 2. The standard deviation would be 1, and then the mean would be 0. And this prevents data with large scales, like median income, from dominating very small values, like average occupancy. Because like the cost of a house, or the average income can be like thousands, probably $10,000. Well, as you saw with the means, the average occupancy is generally around like 3, or like 1 digit, maybe 2-digit numbers. So it can't really be that high. And one important thing is that you shouldn't normalize everything. You should only normalize the training data, because if you normalize the testing data, numbers will not be correct because it's supposed to give you out the right number, not the normalized version. So it'll do these features, and you can see it cuts down the mean to 0 and puts the standard deviation to 1. So that's what you want. So thanks for watching. I'll be releasing part 2 soon. Yeah. See ya.